Okay, so let's take a look at our new unit, extreme values. So there are certain sets of real numbers called intervals that occur frequently in calculus and correspond geometrically to what's happening with line segments. So we've talked about this before. We can have an open interval where we have the two curved brackets, and that means that it's going to exist between those values but is not equal to. We can have half open intervals where it's going to be not equal to one of the intervals, but it can actually be equal to the other interval. Or we can have closed intervals where it has the squared brackets and it's actually equal to both of those endpoints on the interval. We can also have it where we split it and we say that it's going to be this interval or this interval. If we needed to, we could use the opposite, like this, to say and instead of or. For the rules that we know, if a is less than b, then if I added another value, say c, to both sides, it would still be equivalent. If a is less than b and c is less than d, because a is a smaller number and c is a smaller number, if I combine a and c, it has to be less than a and b. If a is less than b and c is greater than 0, then if I multiply a and b by a number that's greater than 0 or a positive number, then a times c is still going to be less than b times c. The one that we get stuck on is if c is a negative number, when I multiply by a negative number, the direction of the inequality changes. Even though 5 is less than 7, negative 5 is greater than negative 7. So when I do that negative, it's going to make it further away from 0 for the bigger number. And if 0 is less than a, which is less than b, then the reciprocal of a has to be greater than the reciprocal of b. Remember, as we've already talked about, if we multiply or divide both sides by a negative number, the direction of the inequality symbol reverses, and it's going to go in the opposite direction. So for this first example, if I said that 5 minus 2x is greater than or equal to 7, then negative 2x is going to be greater than or equal to, when I subtract 5 from both sides, 2. And when I divide both sides by negative 2, remember, when I'm dividing by a negative, it's going to change the direction of that sign. And in this case, x is going to be less than or equal to negative 1. Then I can put that on my number line, where I have the point of negative 1. Because it's equal to, it's going to be a solid dot, where it's going to be closed. And then because it's less than, it's going to go to the left. For example 2, if we're dealing with a quadratic, then the first thing I would do is I would find the roots for the quadratic, regardless of if I'm doing it graphically, doing interval tests, doing the case analysis method. I always need to find the roots. So I'm going to start with the roots. And the roots are going to be based on, well, let's factor this. So I'm going to factor it to x plus 3 and x minus 4 is less than 0. The roots of the left-hand side here are going to be x is equal to negative 3 and x is equal to positive 4. When I graph out my quadratic, then it's going to be opening upwards because I have an a value of 1, and I'm going to have those roots at -3 and at +4, and it's going to look something like this. Now we can see from the original function, it said when is this less than 0, which means that it's specifically asking for when it is below the x-axis, and it's below the x-axis in between these points, which means that the x values where it is below the x-axis, or the domain where it's below the x-axis, is going to be in between -3 and 4. So what are we going to say? We're going to say that x is an element of, open bracket, -3 and 4, or we're going to say that x, where -3 is less than x, which is less than 4, and x is an element of real numbers. If I'm doing the interval test, well, I'm still using my roots. I'm still using that factored form that we took where we said that x -4 and x + 3 is less than 0. I know that that's going to be with the roots of -3 and of 4. And it's going to split into these 3 intervals. The first interval here, where x is less than -3 or -infinity is going to -3. It's going to have a second interval where it's between the two, where -3 and +4. And it's going to have a third interval where it's greater than 4, or 4 and infinity. And I'm going to use that on my chart. So I'm going to state along the left-hand side, I have my intervals that we just said. I'm going to have the interval of -infinity and -3. I'm going to have the interval of -3 and 4, and I'm going to have the interval of 4 and infinity. On the top, I'm going to state my factors. So we had the factors of x -4 and x + 3. And I also need to know the product. What happens when I multiply whatever the number is going to be. So if I pick a number that is in between -infinity, so less than -3, then any number less than -3 is going to make this negative. It's going to make this negative. If I pick a number between -3 and 4, so say 0, then this is still going to be negative, but 0 + 3 is going to be positive. And when I pick a number bigger than 4, say 10, this is positive and this is positive. So then I'm going to multiply the factors going from left to right, and a negative and a negative makes a positive. A negative and a positive makes a negative, and a positive and a positive makes a positive. And what did it say about our original inequality? It wants it to be less than 0. Another way of saying less than 0 is negative, which means there is my solution. X is an element of -3 to 4, just like what we found when we graphed it. When I do my case analysis, well, for my case analysis, what do we know? We know that we have case 1, And we have case 2. For case 1, how do we get a number that is less than 0? Well, that would be the same as a positive times a negative, or one factor, x plus 3, is greater than 0. The other factor, x minus 4, is less than 0. For case 2, it's going to be negative and positive, or x plus 3 is less than 0, and x minus 4 is greater than 0. This is going to be when x is greater than negative 3 and when x is less than 4. This is going to be when x is less than negative 3 and when x is greater than 4. And then I can just put it on a number line. What's this going to look like? Well, I'm going to have when x is greater than negative 3. I'm going to have when x is less than 4. And when are both of these things true? They're both true in this region. In the other case, I'm going to take when x is less than negative 3, when x is greater than 4. And when is this true? Well, they never overlap. So in one case, I have it where x is an element of negative 3 and 4. In the other case, I have no solution region, which means that that is the only possible solution region, which we already found with our previous examples.